What really happens to the clothes you throw away? Do they simply disappear, or do they end up somewhere quietly piling up beyond our sight? Every year, the world produces more than 92 million tons of textile waste, yet less than 15% of it is ever recycled. That means every single second, the equivalent of a truckload of clothing is either buried or burned. But what if that wasn't the end of the story? What if, hidden behind massive industrial systems, these discarded materials are not treated as waste, but as resources waiting to be transformed? This is where the journey begins. Not with fashion, but with machinery, precision, and a process that turns chaos into structure. And once you understand how it works, you begin to see that waste was never truly the end. It was just the beginning of something else. The process begins far from the recycling plant itself. Across cities, shopping centers, and donation networks, used clothing is collected in massive quantities. Globally, millions of tons of textiles are discarded each year, and a significant portion of it never even reaches a recycling system. Instead, it is sent directly to landfills or incineration facilities. But for the materials that are recovered, transportation becomes the first step in their transformation. Bales of compressed clothing are shipped across regions, sometimes even across countries, arriving at recycling plants where their second life begins. At this stage, the materials are still intact, still recognizable as garments, but their original purpose has already ended. Once inside the facility, the materials enter one of the most critical stages of the entire process: sorting. At first glance, everything appears chaotic. Different colors, different fabrics, different conditions, all mixed together. But this stage brings order to that chaos. Workers in automated systems separate textiles based on fiber type, color, and usability. Cotton is separated from polyester, natural fibers from synthetic ones, and reusable materials from those that must be discarded. Even color plays a role, as grouping similar shades reduces the need for chemical dyeing later. Small components like buttons, zippers, and labels must also be removed, as they can interfere with the recycling process. This step is time-consuming and requires precision, because even a small mistake here can affect the quality of the final product. After sorting, the textiles move into the mechanical core of the recycling line: shredding. Here, large industrial machines equipped with rotating blades begin tearing the fabric apart. The process is continuous and powerful, capable of processing tons of material every hour. Fabrics are pulled in, stretched, and ripped into smaller and smaller pieces until the original structure completely disappears. Within seconds, garments lose their identity. A shirt is no longer a shirt, a jacket is no longer a jacket. Everything is reduced to loose fiber. However, this is not uncontrolled destruction. The machines are carefully calibrated to ensure that fibers are not cut too short, preserving their strength for later use. This balance between breaking down and preserving is what makes the process effective. Following shredding, the fibers are filled with dust, dirt, and microscopic contaminants that must be removed. Cleaning systems use a combination of airflow, vibration, and filtration to separate usable fibers from unwanted particles. High-speed air currents lift lighter materials while heavier debris falls away, and vibrating screens help release embedded impurities. In some facilities, magnets are used to extract tiny metal fragments left behind from zippers or fasteners. This stage is less visible, but critically important, as it directly affects the quality and consistency of the recycled material. Without proper cleaning, the fibers would not be suitable for further processing. Once cleaned, the fibers are reprocessed to restore structure and usability. Through carding machines, the fibers are aligned, straightened, and separated into a more uniform form. However, recycled fibers often lose some of their original strength during earlier stages. To compensate, they are frequently blended with new fibers, sometimes making up 20 to 50% of the final mix, depending on the intended use. This combination allows manufacturers to maintain durability while still reducing the need for raw materials. At this stage, the material is no longer waste. It has become a functional input once again. At this stage, the process shifts from reconstruction to refinement. The loose, reprocessed fibers, once chaotic and fragmented, are now guided into spinning systems where precision becomes everything. Inside these machines, the fibers are stretched, aligned, and twisted into continuous strands of yarn, moving at carefully controlled speeds that balance tension and stability. Too much force and the fibers snap. Too little and the structure fails to hold. Every movement must be calibrated down to the smallest detail. As the fibers twist together, something remarkable begins to happen. The material regains its integrity. What was once broken apart is now reassembled into a form that can carry load, withstand stress, and function again in the real world. This is more than just a mechanical step. It is the moment where disorder becomes structure, where fragments become continuity. Thread by thread, the system restores what was lost not by returning to the past, but by creating something entirely new from it. After the yarn is formed, the transformation is still far from complete. The material now moves into finishing and dyeing where texture, color, and identity are carefully redefined. The newly formed fabric is first treated through enzyme washing, a process that softens the fibers and removes any remaining roughness left from earlier mechanical stages. What was once coarse and uneven begins to feel smoother, more refined, more controlled. From there, the fabric enters high-pressure dyeing systems, where color is no longer simply applied but engineered. Using advanced spray technologies in controlled environments, dyes penetrate deep into the fibers, ensuring consistency across every surface. In the case of recycled denim, the process becomes even more specialized. The yarn is repeatedly dipped into indigo dye baths, layer by layer, building depth and character over time. Then, it is woven using the traditional twill structure, a diagonal pattern that gives denim its strength and signature look. At this stage, the material no longer resembles waste in any form. It has become fabric again, defined, structured, and ready to be shaped into something new. With the fabric fully prepared, the process shifts once again from material to product. Digital patterns are used to precisely cut the fabric, minimizing waste while maximizing efficiency. Every cut is calculated, every shape optimized. The pieces are then assembled through automated and manual sewing systems, where flat fabric is transformed into three-dimensional garments. Stitch by stitch, structure returns not just as material, but as function. In the case of denim jeans, additional components are integrated with industrial precision. Copper buttons, metal rivets, and leather labels are attached using hydraulic presses, ensuring durability under repeated stress. At this point, the transformation becomes tangible. What once existed as discarded fibers is now recognizable, again not as waste, but as clothing, ready to be worn. But even now, the process is not complete. Before reaching the consumer, each garment undergoes a final stage of refinement where aesthetics and quality are brought into focus. Skilled workers apply finishing effects using techniques such as sanding, stone washing, and high-pressure water jets. These processes create natural fading patterns, giving each piece a worn, authentic appearance. No two garments are exactly alike. What was industrial now carries individuality. After that, every item is carefully inspected under strong lighting conditions. Imperfections are identified, corrected, or removed entirely. Only those that meet strict quality standards move forward. Finally, the garments are folded, packaged, and prepared for distribution, ready to leave the factory not as recycled material, but as finished products entering the world once again. But the journey doesn't truly end when the product leaves the factory. From this point forward, it begins another cycle, entering stores, reaching consumers, and becoming part of everyday life once again. A pair of jeans, a jacket, a piece of fabric now worn, used, and lived in, carrying a new story that no one can see. And somewhere in that story lies a quiet truth. What we consider new is often built from something old. Over time, these products may once again wear out, fade, or be discarded. And when that happens, the cycle has the potential to begin again. Because within the right system, there is no true ending, only transformation. The same material, moving through different forms, across different lives. What changes is not the substance, but how we choose to use it. In the end, what you're looking at isn't just a recycling process, it's a complete redefinition of what waste actually means. Because the truth is, these materials were never useless. They were never meant to disappear. They were simply waiting for a system capable of understanding their value. Every fiber, every thread, every piece of fabric that once seemed forgotten is still here, still moving, still becoming something else. And maybe that's the most powerful part of it all, not the machines, not the scale, not even the technology, but the idea that nothing is ever truly lost. It only changes form, again and again, across different lives, different purposes, and different moments in time. So the next time something feels like the end, it might just be the beginning of something you haven't seen yet.